Hello. Let's talk about this horizontal launch quiz. Let me know when you're ready. We can talk about the different properties of horizontal launched objects, and then we can talk about how to solve a horizontally launched object. I have until about 9 o'clock, and then I am done. Okay. Please keep in mind that you need to make sure you write down all your givens and asked for this. Hopefully this microphone is working well. I don't even know. Hopefully. Okay. Please ask questions. A horizontally launched projectile is something that starts from a height and is launched out horizontally. Now, because it is not on a surface, it's going to start to fall as it travels. And that should make sense because if you throw something or launch something horizontally, what's going to take over as it flies through the air? Gravity. Gravity is going to make the object fall. So that's how we get our parabolic path, okay? And you heard the keyword fall, okay? This is your parabolic path. This is what the object is going to do because of gravity. Gravity is the only force in the y plane, meaning the vertical plane, that is acting on the object. Okay, gravity is what makes the object fall. So in the vertical plane, the object is experiencing free fall motion. That is one of the properties of a horizontal launch. So make sure you know that, because all of the properties of a free-falling object, oh, sorry, this is backwards. I don't know how to change that. You'll have to figure that out. Okay. Okay, so vertical motion is free fall. I'm not good. I'm not going to write backwards. Sorry. Okay, so an object that is falling, what do I know? Well, I know from my previous chapters that a falling object has an initial velocity, v0, of 0 meters per second. I know that the acceleration in the y direction, ay, is going to be negative 10 meters per second squared. Those two things I can automatically write down for all horizontally launched projectiles. Okay, so anything that says horizontal launch, you know the y direction is free fall motion. Vy0 is 0 meters per second. Remember that velocity is different than position. Velocity or speed is your variable v, and your position is y. Okay? Your initial position, your y0, is not ever 0. Y0 has to be some height because you're starting up and the object is going out and down. So Vy0 is 0. Y0 has to be something meters. Okay? If the object goes all the way to the ground, then your position will end at 0 meters. but I may ask you for how fast is it going 150 meters above the ground. I can do that. Okay. It just is going to depend on the actual problem, the actual circumstance. So why your final position is not always 0. But if I says hits the ground, then it is. Okay, so I left a note card activity for you guys to do on Friday. Basically, what you were supposed to be able to do is match the variables with the givens and then find anything that was being asked for. And a lot of the problems I asked for time, velocity, and some sort of distance that was traveled, either x distance or y distance. So if you were able to find all of the answers for every single problem that was in the note card activity, which I sent all the answers to the 3 teachers, so they should have had them. If you were able to do that, then the math portion of this quiz should be very easy for you. And the concept questions, I think, are no-brainer. They're just kind of freebies and kind of reminders like, oh yeah, when I'm doing my math problem, it's only accelerating in the y direction and never accelerates in the x direction. I can only use one equation in the x direction. Remember that free fall is the y direction. So I know my velocity that I start with 0. 0 is always 0. AY is always -10. Okay, those two things I'm not going to give to you. Those are things that I expect you to remember because we've already did a whole chapter on that for free fall, and now we're just reusing it in a different way. If you did not get answers for the note card activity, I can give them to you. That's not a problem. I have them. But I don't have, all I have is the givens and the answers. I don't have the equations and I don't have the work done for you. That's something that you were supposed to be able to do. Any other questions? I hope you guys can hear me okay. All right, so I guess I'm going to just give you a problem to work on. And then I'm going to have to go. So if I told you that an object is launched horizontally with an initial horizontal velocity of 13 meters per second from a height of 175 meters, and I ask you what is the speed when it hits the ground, there are certain things that I expect you to be able to do. Okay, the first thing is that you recognize what's being asked for. If I ask you for the speed when the object hits the ground, that's your resultant vector velocity. That is not just Vy, and that's not just Vx. You have to have both Vx and Vy to find the Vr. Okay, so Vr is the speed when it hits the ground, and that was last unit's objective, was to prepare you to find the hypotenuse. So you launch an object first horizontally, and I said it's launched at 13 meters per second, and that's your VXO. Okay, so I'm launching the object horizontally at 13 meters per second. Then it's going to fall and hit the ground. Okay, and that's my Vy. I don't have my Vy yet, so first I'm going to have to find my Vy, the speed in the y direction at the bottom. Okay? Because then I can find my resultant, which is Vr. Okay, so this is what I'm starting with. Remember, I said that the height that I'm at is 175 meters in the air. Okay, I know it's backwards, but you guys can turn it around if you need to. All right. Using the information I have right now, I can't find my Vy and I can't find my Vr. So what I need to do first is find T, okay? And I'm going to use the vertical direction to find T. I'm going to use equation number 1. And I'm going to find T. If you remember that this is a free fall in the vertical direction, you'll know that this term right here becomes 0 because Vy0 is 0. So you can actually cross that part out. So I'm going to plug in the information. I know that it's going all the way to the ground. It starts at 175 meters above the ground. The acceleration is -10. And I'm looking for T. And this is going to be on playback, so you can watch this and pause this later if you want. Okay, so finding T. Solving, you will get a T of 5.9 seconds, and that's rounded. Okay. Once you get that, then you can find Vy using equation number 3. Remember that Vy0 is 0 still. Okay. Remember, I'm showing you all of the work. The only thing I didn't give to you or list for you is the asked fors. I do expect you to show that to me on the quiz because I need to see, remember, I'm grading these. I need to see what you do know and what you don't know, okay? So you need to make sure you're showing me all of your work. Okay, so now my Vy is negative 59 meters per second. So I can go back up to my picture and plug in my magnitude. Notice I don't have to put the direction next to this because it's already going down, okay? Remember, negative means down or left, and in this case, we're in the y direction, so it's down. The arrow already tells you that 59 is going down. So now that I have the two magnitudes for v's, vx, and vy, I can find vr using the Pythagorean theorem. Okay, and then I get the answer of 60.4 meters per second. That is my VR. Okay. If I was to ask you to find the angle, then you would just do the tangent inverse. Okay, and you would you're using y over x. Okay. If you have any other questions, feel free to send me a message. It is now time for me to put my children to bed. Good luck tomorrow. Please practice, practice, practice. That's all you really can do to prepare. Okay? Kind of like playing a sport or an instrument, practice makes you better.